Hey, thanks for watching Practical Solutions. My name is John, and today we're going to go over the DMVPN Phase 1 design and configuration. So as you can see on the left here, designing the network, we need just two networks. We need an overlay and an underlay. So our underlay is going to be a 10.0.0/24, and then our overlay is going to be our 172.0.0.0/24. Our underlay network is going to be our transport, so we're just going to configure the interfaces and verify the connectivity. Then the overlay network, we're going to throw a DMVPN on top. We're going to configure the tunnel, NHRP, routing, and then we'll verify. Now we don't have an underlying configuration as far as routing. In reality, you probably have BGP or something underlying if you're talking to your ISP or OSPF, depending on what you have for your edge devices. In this case, we're pretty much just going to let the DMVPN act naturally. With our point-to-point that we already have established here, and we know we can get connectivity, I'm not going to worry about it. But over the actual internet, there'd be a little bit more configuration. But in a lab environment for studying, this is perfect. So I'm going to jump into configuring the hub first, and then we'll jump into the branch. So let's jump in the hub. Config T, we'll throw hostname on here. And then we'll configure the interfaces for our transport. So the IP address for gig00 is going to be 10.0.0.1 to /24. Description, we'll just put internet and no shot. And now we have our interface gig00 should be up. All right. So that's all set there. Now we'll go to the branch, enable, config T, give this a host name as well. We'll just call this branch. We'll go to interface gig00 as well. Add an IP address. We'll do .2, same /24. Description, we'll put internet on here. And then we'll go ahead and no shot. End. Now if I wanted to, you could throw static routes with all zeros. So if I wanted to, I could do a config T and do for an IP route. I do IP route. And I could just send it to the next hop, which in this case is going to be .1, and then have .1 send it to .2 and a point-to-point, so we know where they're sending everything. But we don't really need this in EVNG. It kind of works in our favor. But if you needed to put routing, or you wanted to put routing for your underlay, which you would in a real world scenario, then you can go ahead and do it. But for this, our case in point, to show and prove the DMVPN and what's required for it, we didn't go into that at all. That'll be for another video. All right. So now that we've got the branch configured, let's make sure we can ping across. Just take a second. And we can. Make sure we can ping to the branch, which we can. Cool. Always verify, especially in a production network. You just want to make sure it works both ways, because in most cases you'll be going through a firewall or something else. All right, so on the hub we're going to start building the tunnel. From the tunnel configuration on the hub, it's not too intense. Interface tunnel 0. You can use any number that you like. IP address we're going to throw is a 172.0.0.1. Same. It's also going to be a /24. We'll put a description on there, DMVPN. We'll put a tunnel source as the gig00 interface that we configured. And then we'll put a tunnel mode. It's GRE, but it's not IP. It's going to be multi-point, because as a hub, we're going to have a lot of different spokes registering with us. So we won't technically have a destination. We'll have multiple destinations. Tunnel key, added step of security. We're going to just choose 1, 2, 3. Now for NHRP, which is the next step of the configuration, there's only 3 steps on phase 1. IP NHRP authentication that we need to put on, which we'll use key 1, 2, 3. We'll do IP NHRP map multicast. And then this as well, we're not going to be defining, because we're the hub, we're going to be using dynamic. So we're actually going to be learning this as the spokes register with us. We'll learn their non-broadcast multi-access or underlying internet private IP address, whichever you choose to use. And then we have to go ahead and define our network ID. And we're going to use 1. So if I check out the tunnel, all we have for configuration is the IP address, the NHRP authentication, multicast, dynamic, network ID, source, mode, and key. Now let's go to the branch. Branch, I'll also use tunnel 0 as the name. For the address, we're just using .2, same /24. description, we'll put DMVPN. Helps to spell it out. So for our tunnel source, it's going to be the gig 00 that we have configured. For our tunnel destination, since we're phase 1, the spokes build point-to-point tunnels. So we're going straight to the non-broadcast multi-access IP address of the hub, which is 10.0.0.1. The tunnel key, it was 123 that we used, and then we'll move into the NHRP authentication and into the rest of the NHRP configuration. So IP NHRP authentication, and it is key 123. IP NHRP map multicast. So map multicast is where we're going to be having the hub's IP address defined on the spoke. So that's our 10.0.0.1. IP NHRP NHS for the next hub server. That's going to be your hub, and that's going to be the hub tunnel IP address, which is 172.0.0.1. And then we have to map it all together. So IP NHRP map, and now you're going to map the overlay, which is 172.0.0.1, to the underlay, which is 10.0.0.1. So you're going to map the tunnel IP address to the non-broadcast multi-access or underlying IP address that you have for the hub. So that takes care of our mapping multicast, our map, our NHS. We got to do the network ID now, which we chose 1. So if I do show run interface tunnel 0, we can see we have the authentication, the map multicast, the map, the network ID, NHS, source, destination, and key. So NHRP acts as kind of like a routing protocol where it's selecting exactly where everything is going. So it's almost like you have statically defined routes and statically defined peers, especially in a phase 1. To clarify this, I'll do a show DMVPN. As you can see, the DMVPN is up that we have established. We have our peers, which we've defined on the branch. This is the hub's underlay, and this is the hub's overlay. The state is up, and then how many hours, minutes, and seconds it's been up. The attribute is static because we've defined it. And if we go back to the tunnel configuration, this is where we've statically defined the hub, and with our tunnel destination as well. So we've statically defined that everything is going to be sent to the hub. If I go on the hub, and I do a show DMVPN, we see the hub has the same peering, but with a branch. And the state is up, same hours, minutes, seconds, and the attribute is D for dynamic. Dynamic is because the hub learns the spokes they connect to the hub. As you show in the configuration, there's nothing here to state any of our peers. So all the peers that we learn are going to be dynamic. Now, as far as routing goes, if we're going to slap on any type of routing configuration, you can use static routing. But if you want to use EIGRP, we'll go ahead and we'll do that next. So on the hub, config T, router, EIGRP1. We'll do no auto summary because we don't want to send any summarized routes. We want to send just what we have with no summarization, especially with EIGRP over DMVPN. It's a Cisco best case, best use. We'll go ahead and also add our network, which is going to be our 172.0.0.0. And it is going to be the wildcard bit, so 0.0.0.255. So it's that whole /24 network that we're adding into EIGRP. Now we'll go into the tunnel. On the tunnel, we have to go ahead and shut off split horizon. So it's no IP, split horizon, and then we define its EIGRP and the autonomous system number that we're going to be stating no split horizon. That means any routes that you learn on one interface can also go out and be advertised that same interface. Split horizon prevents that. This is allowing it. So we do show run interface tunnel 0 on the hub now. You can see that we have the no IP split horizon. And that's only on the hub because the way the hub is working. You'll especially need that once you start moving into more tunnel-to-tunnel configurations where the hub has less and less of a responsibility and more or less is just redirecting the spoke traffic to spokes. On the branch, we'll do config T, router, EIGRP1, add our network. Before we do that, let's add the no auto summary. Now we'll add the network. It'll be 172.0.0.0, and it's our wildcard bit. All right. Show DMVPN. We still have a good solid connection. Show IP EIGRP neighbor, and we have built our EIGRP neighborship over here and All right, we got our DMVPN, we have our neighborship, EIGRP looks great. So as you can see on the hub, this is all that we have configured for a phase 1, as well as our routing protocol. So we'll pull up EIGRP here. So that's all that we have on the hub as far as the configuration goes. And then we have our underlying configuration as well. So show run interface gig 0, 0. So that's it. That's the entire hub configuration that we have right now. And then for a branch, we'll also do show run interface gig 0, 0. And we'll also do our routing. So on the branch, this is all that we have configured on the branch. For a basic DMVPN with EIGRP as your overlay routing protocol, this is all you need. Some other things that you can go ahead and troubleshoot would be show DMVPN detail. Show DMVPN detail in the next videos when we throw on our crypto and everything else that we want to add onto the tunnel and start going to different phases. You'll start to notice a lot more of this information will be populated, especially as we add different nodes. And then as we move into the phases, you also see that some of the spokes can learn dynamic as well, because you allow spoke-to-spoke traffic in the next coming phases. As far as for NHRP, show IP NHRP, there's tons of things you can look for NHRP. For the most part, I just use show IP NHRP summary, and that'll give me what I have built as far as static, dynamic, incomplete, and then how many entries I have. Another thing that I've seen a lot of people use is brief. Brief as well is great. It shows you everything for the interface, and then what you have for next hops, and then what those non-broadcast multi-access IP addresses are. So this is also very good for troubleshooting as well. On the hub, you can do the same thing. Usually you'll have a lot more detail on the hub because you have a lot more spokes, especially in a phase 1. Most of your information is going to be on the hub. And that's it. Thanks for watching Practical Solutions. I hope this helped you learn a little bit more, or at least explained a little bit more about DMVPN. If you have any questions, drop them in the comments section. Appreciate it. Thank you very much. Take care.